Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I would like to thank all of you for attending today's webinar with RF Elements. Today's host is Tassos, and he'll be presenting today. And if anyone has any questions, please feel free to submit them in the question box. And at the end of the presentation, Tassos will address them. Tassos, I'm finished for now. Please go ahead, and the floor is yours.
Great, thank you. Good morning, good afternoon, everybody. My name is Tassos with RF Elements, and today we'll be talking about a new webinar we have called Increasing Throughput 101, right? So this webinar is basically a kind of how-to guide of using our antenna technology, our symmetrical horn antennas, to help increase the throughput and capacities of your APs and your towers. So if we look at the challenge today as a WISP, right, the main challenge is keeping up with the demand for throughput, right? So if we look at internet usage as number of users year over year, we see it growing, somewhat almost exponential, right? And not only do we see the number of users growing or the demand for internet to people and devices over the years, but on top of that, we have the demand for higher and higher throughput per user growing at a pretty fast rate as well. So this chart represents the increase of average speed per user over the last 5 years, along with the number of users in billions over the last 5 years as well. So the demand is going up pretty fast. So if we look at the challenge in delivering, the demand for a number of users that are requiring internet connectivity and the demand for higher and higher throughput, the main challenge in delivering and achieving those goals is the lack of spectrum, right? Spectrum is our problem. Globally this changes too, because if you look at spectrum, there is a lack of spectrum in some areas in the amount of actual legal spectrum you can operate in. So that could be a limiting factor in some areas. But of that legal operating spectrum, the inability to use that spectrum efficiently with today's current technologies from mainstream vendors compared to RF Elements, it's a huge challenge, right? So to cover that growing demand, new standards are coming out with higher theoretical speeds and more complex modulation rates, right? This is how the radio manufacturers are dealing with, the growing demand for delivering higher and higher throughput to more users is, create radios that can go faster and deliver more bandwidth. The major problem there is that these new techniques require way more spectrum, and we know that's limited, right? And the spectrum today is basically limited to, it's limited because of the high amount of RF interference that's out there, right? And that interference is coming from the use of the traditional sectors that are being sold from the mainstream vendors, right? So wireless vendors now are trying to bring much more advanced technologies and much more complex solutions like TDMA, GPS synchronization, and active filtering to address these issues. And really, those things are really not the solution for the original problem of the RF interference that's being out there. So again, the problem is RF noise, right? And your current vendors are not really solving the problem at the roots. They're kind of dealing with the consequences, and this is really the wrong approach, right? So RF Elements takes a whole nother approach into solving the root of the problem, is not generating noise and being immune to noise, rather than create these complicated mechanisms to just kind of coexist in the noise and not deal with the actual problem. So if we look at some of the poor solutions for interference today, we see what, again, mainstream manufacturers are doing to deal with this interference issue. They're building higher and higher gain antennas to talk over the noise, which generates even more noise. Vendors are creating shielding kits to try and make these, inadequately created antenna systems, more immune to noise, and this causes other issues because they may filter or help block some of that noise coming into the antenna, but they're having really adverse effects on the main beam. The part of the antenna pattern that are reaching your customers are not sufficient in delivering high bandwidth. So it creates other issues that you can see to deal with a kind of smaller issue on the front end. If we look at the mainstream vendor solutions for the radio solutions that are out there, we can look at, in the beginning, we had 802.11n, right? So that was a way to deliver more bandwidth, utilizing, slightly wider channels. And now we look at, GPS synchronization coming in, and now, radios with GPS synchronization, and on top of that, we also have, active filtering. So many things are happening there on the radio side to try and deal with noise, but really they should be dealing with, the root of the problem, and that's not creating noise, basically. So RF element solution, what do we do? How do we deal with the source of the problem, right? Basically, we create antennas that reject noise, and antennas that have extremely precise radiation angles, right? So our signals go out only in the intended direction that you choose. They are typically spec'd at lower gain, right? So they don't propagate or hear noise from further distances. And we have an antenna system that incorporates our proprietary twist port mechanism, right, which helps reduce loss, right? So by having less loss injected into your antenna delivery system, you get a much better, more balanced solution. So we reject noise, and we have a zero to low loss proprietary waveguide system that helps us deal with the problem at the source, right? Oh, sorry, too far. 1 second here. I want one slide too many, I believe. I apologize. Okay, here we go. All right. So if we look at noise rejection, so if we look at traditional antennas, this is the radiation pattern. Some of you may have seen these before. Traditional antennas have not only very wide angled main beams, but they also have huge side lobes. And these huge side lobes are a huge problem not only for hearing noise, so this brings down the performance of your radio system, but also for sending noise, right? Because these side lobes are pointing in directions where your customer's not supposed to be. So you're sending radio signals in directions you're not really intending to. So this is how you create unwanted noise. If we look at a horn antenna pattern, you see that the radiation angle is very precise with no side lobes. So you're basically only sending the signal in the direction you want at the angle that you want. So you're not creating extra noise by sending signal out on side lobes, but you're also rejecting noise because, again, those side lobes are usually really high intensity receivers, right? So we get very high noise rejection with horn antennas because they have no side lobes, and we have them in a variety of angles, so you can have very tight beam patterns compared to traditional sectors. The same thing happens if we look here. We're looking at actually what parabolic dish antennas look like. So parabolic dish antennas are often really misunderstood, right? Because they have such high forward gain, which gives them really narrow main beams. And it's thought and understood that this narrow main beam is the greatest source of isolation for the antenna. And this is true. However, it's really not taking into account the huge and very complex side lobes of parabolic dish antenna technology. So if we look here, you can see that the side lobes are huge. Many companies actually create shielding kits, and some of the antenna manufacturers are creating these antennas with shielding or shrouds, as they're called, those kind of barrels that go around the outside perimeter. And those things are only really made to kind of suppress, those first two side lobes that shoot out at almost 90 degrees from the antenna itself. It does nothing to really suppress those other two main lobes that come out with the, above and below the main lobe. Those side lobes usually exit the shroud and therefore give you a much wider actual angle than you would expect. So again, noise rejection through parabolic dish antennas is actually quite low because of these side lobes. If we look at the same type of high gain horn antenna here, again, you see practically zero side lobes. So all you have is that main lobe. So that's the key point to major isolation with a horn antenna compared to other point-to-point antenna technologies. So the zero loss system we spoke about earlier. So if you look at traditional radio systems, you have a radio, you have a pigtail interface, and then you have the antenna. So our zero loss system actually removes that part of the equation, right? So you basically take the transmitting waveguide element and you integrate it into the radios. There are no pigtail connections, and therefore you get a much cleaner, less loss in the actual transmission of signal from radio to antenna. It's a much cleaner, better, more efficient way of delivering your RF signal to your antenna system. So it's very important. And people don't always understand. They think, well, all right, so maybe I have 1 or maybe 3 dB of loss because of those pigtails. So I'll simply just induce another 2 to 3 dB of TX power on my radio because the radios are capable of doing that and still stay within your EIRP limits. And what most people don't understand is that they're trying to achieve, MCS 9, right, the highest modulation rate in AC to get the highest bandwidth. But most radios are incapable of sustaining, maintaining, and receiving MCS level 9, the highest modulation rate, if you go beyond like 20 or 21 dB of TX power on the radio, right? So by going to 23, 24, maybe even 25 to counter the loss of the pigtail, you're unable to maintain those higher MCS rates, right? So it's really important to have zero loss, so that way the TX power of the radio can be as low as possible and still deliver the end result, the EIRP max that you're looking for if necessary. So it's a much more efficient way of building radio systems. Really, pigtail systems is kind of really old school, and the industry needs to change their ways. So let's look at basically a patch array. That's a traditional sector is built on patch array technology versus horn antennas. So if we look at the beam patterns of a patch array, there's usually in MIMO systems 2 polarities, vertical and horizontal. And what we can see is there's huge mismatches, right, in the coverage areas. The vertical width and the horizontal width often do not match. So if you buy a 90-degree sector, it might be 80 degrees in vertical and 120 in horizontal, and the average of those two are 90, right? So you don't get very good chain-to-chain performance throughout the complete coverage area. Also, gain is not the same throughout that coverage area. So if you look at here, if you look at your kind of customer deployment throughout your coverage area, typically the customers that are kind of in the center of that beam, right, get the best signal, the highest quality. Gain is matched. You have chains matching. As you start moving towards the edge, you start getting mediocre to poor signal on the edge, right, where a horn antenna has identical vertical and horizontal beam performance. So all your customers that are in main beam connectivity are getting good signal, and you get a much better higher quality of service no matter where they are. So that's kind of the difference between a traditional antenna and a horn antenna, and why they're far more superior for performance. So now we'll look at noise rejection. So if we look at this kind of deployment here, you have your standard tower with a traditional sector on there, right? So you're covering your coverage area, and because of noise on a traditional sector, your throughput, your total link throughput of that AP can be reduced, right? Because you have noise, because of the customers that are on the outside, the edges of that sector getting poorer performance than the ones in the sweet spot of a traditional sector. With a horn antenna, because of the noise rejection, because of the balanced beam, you get much better link throughput because all your customers get the higher modulation rates and all your customers get a better signal delivered. So overall, the performance is much better because of the noise rejection qualities of horn antennas. So if we look at this scenario here, again, you have a traditional sector. Oh, sorry. Next slide. I apologize. Okay. So co-location, right? So this is another key issue in delivering high bandwidth is co-locating, multiple APs on a tower and how we deal with that, right? So if we look at this particular deployment, you have a, traditional sector, again, covering your coverage area, and your overall throughput of that AP is somewhat mediocre, again, because of the noise rejection issues that we had mentioned before. Sorry. Here we go. So if we, were to use other horn antennas instead, you can actually break up that same coverage area into 3 smaller segments. Because of the noise isolation of horn antennas, you don't get the interference between those APs, so you're actually able to deliver much more capacity. You're allowed to have much more subscribers, and you basically get more overall throughput to that tower because of the co-location capabilities of horn antennas versus traditional sectors. So basically, if we look at, kind of their way, that's the mainstream manufacturers and traditional sector antennas versus our way, the only way to truly grow is by using, more precise radiation angles on your antennas with higher co-location capabilities and much greater noise isolation. This is the only way to achieve kind of the massive scalability that people are looking at. So we go into channel availability. This is often one of the, not the greatest challenges, but the first thing people talk about, right? Is, yeah, that's great, but I have 3 sectors on my tower and I have no more available channels, right? You say that I don't even have the spectrum to put a 4th, a 5th, a 6th, or beyond that to get the AP density. And the main reason for that is because you're looking at spectrum through your traditional sector, right? So if we look at, the first AP here and we look at how it sees things, you have your coverage area and the channel it's on is what it sees, right? But then a second AP, and potentially a third AP fire up to cover the same area or adjacent area. So when you look at the, spectrum scan, you see that those channels are being used. Well, if you were to install a horn antenna to cover that area, those other 2 are not seen because of the price radiation angle, so they're not seen at as high a magnitude as a traditional sector was. So honestly, you do have channels available to use. You just don't know it until you actually use a horn and see what spectrum looks like through a horn antenna, looking at it, through a traditional sector with huge side lobes and, unbalanced beam patterns make it seem like you don't have the spectrum. So horn antennas allow you to be much more efficient with the, the spectrum that you actually have available. So here we'll look at how noise floor is kind of, improved as well because of the noise rejection. Oops, sorry. So if we look at, again, a traditional sector covering an area, you have the frequency being used, and then you have, other sectors that are not covering that same area, but because of your wide beam pattern and side lobes, you actually hear them, right? So that actually creates more noise for you, even though you're not on that same channel, because your AP, regardless of it using a channel that's unused, it still hears the other stuff, and it still needs to be able to disseminate your signal over that noise floor, right? So horn antennas really help reduce the noise floor overall, as well as give you channels that are usable again. So big difference there in how they work and how the noise isolation of a traditional horn antenna gets you over a traditional sector. So let's look at the massive scalability here. Again, this is you know, the kind of thing we're all trying to achieve in this industry, right? Is delivering the, you know, AP density, the client density, as well as delivering more throughput to those customers, right? So the only way to truly achieve that is with horn antennas. So if we look at, again, these kind of deployments, if you were to do them with, you know, traditional sectors, again, you're limited. You know, you may be limited by space, so you can only mount so many on a particular tower, but also you're fighting for spectrum, right? So because of the noise that's created with your competitors or even your own towers elsewhere, you're unable to deliver the throughput that you really need. And because we have so many different horn antennas and different beam angles, you're actually able to segment and co-locate these things in the towers to mitigate your noise, therefore deliver high throughput to each one. So kind of in this illustration, you can see because of the noise immunity, you'd be able to co-locate in the service area, you know, 3 to 5 times more APs than you would with traditional sectors. And with traditional sectors, it would quickly fall apart because, again, they're very spectrum inefficient because they're terrible at managing their beam patterns and being precise and reliable. So it makes it very difficult for you as a WISP to manage your frequencies and reuse frequencies. So, you know, the technology for fast sustainable wireless, again, is RF elements. It's the choice is clear. You know, our horn antennas with, again, the ultimate noise rejection, perfectly, you know, performing beam patterns. Our twist port ecosystem, you know, opens you up to a wide variety of vendors, right? So, you know, at this point, it doesn't really matter who your radio manufacturer is. We have twist port adapters or connectorized horn antennas that allow you to be vendor agnostic, right? So it really doesn't matter who your radio vendor is. As long as you're operating in 5 gig, you can tap into the benefits of our symmetrical horn antennas. And once you do that, you'll finally achieve the ability to you know, to achieve massive scalability on your network, right? So again, the idea here is to be able to deliver more and more throughput to, you know, more and more customers, and kind of reduce your RF footprint, basically. So, you know, to kind of wrap up where things are, you know, so increasing your throughput with horns, these are some of the benefits, right? So, you know, you don't need to spend money necessarily on radios that have GPS sync. The isolation and co-location capabilities of horn antennas are so amazing that people are actually reusing channels on the same tower without GPS synchronization. The need for much wider channels. I mean, people are using 40 megahertz and 80 megahertz channels because they're unable to deliver the bandwidth that they should be with their narrow channels because of noise and because of the poor performance. So, you know, the only way to kind of go beyond that is to run a wider channel and have a radio system that has a higher overall throughput. Well, with horn antennas, there's no need. That's why they're more spectrumly efficient. In some cases, you know, you can deliver more reliable throughput in a 40 megahertz channel with a horn antenna than you can with an 80 megahertz channel through a traditional sector, right? So you can save spectrum by giving yourself the opportunity to run smaller channels and deliver more throughput. This makes you more efficient and reduces your kind of RF noise footprint. And no extra costs, right? So our, you know, antenna technology isn't incredibly expensive. So the cost for you know, gaining the benefits of our antenna system is really low. You know, if you have older radios on your tower, you know, old Rocket M5s or old 802.11n Microtech radios or something like this, or older Cambian radios, there's no need necessarily for you to upgrade to the latest and greatest radios. You know, why not just use a horn antenna and unlock the true potential of the radios you currently have before migrating and upgrading to the latest and greatest technology. So it could save you money in the long run or in the front end, because you don't necessarily have to. Just installing the horn antenna is how you get that more throughput, and you get more spectrum reuse and better efficiency. So, you can save money by transitioning to our symmetrical horn antennas. Oh, sorry. I'm having technical difficulties today. I apologize. One more time here. There we go. Okay. So join our community. We have a pretty active forum. It's getting more and more active every day. It's rfelab.com. A great source of information, pictures and install guides and feedback from customers that are using our antenna technology. So if you have questions, go visit and peruse our forum and see if the questions are answered there for you. We also have social media feeds on our forum, as well as videos, webinars. There's quite a bit of information on our forum as well as our website. So I would definitely check that out if you have not, or if you have questions. Customer feedback. I mean, we have tons. We definitely have lots of customer interviews, people who have used our antenna systems with practically, almost every radio vendor out there, right? Most certainly the more common ones out there. So, if you're running Microtech and wonder if this will help you, if you're running Ubiquity and wonder if this will help you, Mimosa, Cambian, whoever it may be. You can definitely go to our YouTube page and see some of these videos and customer interviews and see exactly what they were facing, the challenges, and how they overcame that, and how RF Elements symmetrical horn antennas pretty much help save, in some cases, their business. So pretty powerful stuff. And then stay tuned, right? So, you can visit our website, rfelements.com, or our forum, rfelab.com, and definitely look us up on social media. We're on practically every platform that's out there, at least all the widely used ones: YouTube, Facebook, Google+, LinkedIn, Twitter. Again, lots of good information out there in social media, not just from us, but from real users, the people you really want to hear from, right? You want to hear what other WISPs are doing. So I suggest that you go check us out on social media, or just contact us direct. Definitely, we'd love to hear from you, either via email, info@rfelements.com, or again, on social media. At this point, we've come to the end, and I'd love to take as many questions as you may have.
Thank you very much, Tassos, for that wonderful presentation, and we definitely have some questions for you.
Great.
Okay, great. So let's get started. First one, what degree does the tilt change the coverage map?
Mm-hmm. Yeah, so I don't know how to answer that, easily, right? So what we'll start with is, in most cases, like 80+% of the installations, zero down tilt is needed, right? So it really depends on what horn you're starting with, right? Obviously, the coverage area from a 90-degree horn compared to the coverage area for a 30-degree horn is much different, right? So the vertical plane changes. I mean, we have much larger vertical beam patterns than a traditional sector. So in most cases, you don't need it because it's much wider. I can't exactly say that if you give it 1 or 2 degrees, you get this much gain drop off. It really depends on which antenna it is. And if you have questions specifically about an install that you're thinking about doing, please, like I said, email us direct, info@rfelements.com, ping us on Facebook or some other social media platform. Definitely get in touch with it, and we'd help you answer your specific question. But again, in most cases, down tilt is not needed. In over 90%, between 1 and 5 degrees of down tilt maximum is sometimes needed. Beyond that, it's a special application where you're specifically trying to beam a signal at a very specific area, right? And again, the down tilt becomes more of a necessity, let's say, with, let's say, our 30 degree, where the beam patterns are much tighter, right? So again, it's really not that easy to answer, but we can definitely tell you if you have questions, just ask us direct. I hope that helps.
Thank you, Tassos. That definitely helps. You mentioned the acronym TDMA. Can you tell us what that stands for?
Yeah, TDMA is that time division multiplexing access, right? So TDMA is basically the kind of proprietary mode that almost all radio vendors have, right? So Microtech has Endstream, that's their proprietary polling algorithm, right? So that's the time slots that are created and says, you know, CPE1, you talk at this time, CPE2, you talk at this time, CPE3, you talk at this time. It helps reduce collisions and it's supposed to make radios a little bit more efficient. If you're running Ubiquity, they call it AirMax, that's their TDMA. If you're using Cambian, I'm not sure what they call it, but basically it's that TDMA timing that they use. It's a proprietary polling algorithm that's used to basically tell the client devices when their time slot is to transmit.
Thank you very much. Tassos, can you tell us when the ultra horn antennas will be available?
Oh, God, I love that question. You know, unfortunately, no. I don't have an exact date. They certainly have not started manufacturing, right? So they're not, you know, about to start. They're not on a boat. We're hoping this summer. We really, you know, feel the pinch. I mean, everybody's asking us for us. We know that there's huge demand. You know, we apologize for not having it sooner. But right now, the best I can give is probably this summer. So like, you know, June, July, August, or something like that. But don't hold me to it.
Thank you very much. Well, let's see here. RF Elements manufactures great horn antennas. Who would you say is your nearest competitor in regard to horn antennas, and what differentiates you from them?
Yeah, I mean, I've actually been asked this same exact question before. You know, to be perfectly honest with you, I still stand by there is no competition right now, right? Our antenna, our symmetrical horn antenna, is incredibly unique. We have a proprietary, you know, twist port mechanism, which creates this whole ecosystem that makes our antennas, you know, vendor agnostic. So you can use it with multiple radio vendors. Our horn antennas also come with connectors on them, so you can use them again with other radio manufacturers that are, you know, not part of the twist port ecosystem. Our antennas have been around for 3 years, right? We brought this concept to this market, right? So you know, our antennas are proven. Our antennas are well built and reliable. Our antennas are certainly of a much higher caliber than you know, any other horn antenna on the market, if there is any. So yeah, quite honestly, you know, there is no competition for our horn antennas at the moment.
Thank you very much for that. That's a great answer. With the usage of ultra horns, are all shielding needs negated?
Absolutely. With the use of any of our horn antennas, all shielding is not required. The only shielding that may be required is on your radio. It depends which radio you're using, right? So you know, the radios are getting better as far as the manufacturers. A lot of the manufacturers are moving away from the cheap plastic things, right, and building metal cases. But as far as the antenna itself goes, it's inherently shielded, right? So absolutely no shielding, no shrouds, no reflectors, nothing. The last thing that you would want to do to a horn antenna is do what other antenna manufacturers have done over the years, and that's over manipulate or manipulate the perfectly balanced beam that comes out of here. So you do not want to do shielding of any sort on a horn antenna, whether it's the ultra horn for point to point or the symmetrical horn, the regular symmetrical horn for point to multi-point. No shields, stay away. If somebody says you need shields for your horns, run away.
Thank you, Tassos. Next question for you. What is the feedback for running 50 of the 80-degree antennas for a full spectrum in the event 360 is not available? Will this cause self-interference?
No.
Oh.
Yeah, I heard the background 5, right? So
Yes, five of the 80-degree antennas. Thank you.
yeah. So all of our horn antennas have very precise radiation angles. So whether you're using a 30-degree up to a 90-degree, you still get the collocation capabilities, right? Because the beam patterns fall off sharply. Now, a horn antenna is still an antenna, and it should be treated as such in that, the more space between antennas you give it, whether it's a horn or a traditional sector or any other type of antenna, the more space between them, the better. That's always the case. The difference between a horn, because of the co-location capabilities, are so high compared to traditional sectors or other antennas in the market, you can get away with much less space. So we have customers using 12 30 degrees for 360 degrees with no problems. We have customers using 6 60 degrees for 360 degrees coverage with no problem. So using 5 80 degrees would not be a problem either, or 4 90s, right? So again, the kind of standard rule of thumb is try and have the antennas at least 1 foot away from each other. Again, if you have the room to give it 2 or 3 feet, even better, right? So use as much as you can. Don't pack them too tight if you don't have to. Save that space for when you need capacity. Then you could throw a second antenna in between that first and second one where you have, 1.5 feet of difference or something like that. So give it as much space as you can. You'll get the best performance, and only close that gap for, spatial diversity between antennas when you need to.
Thank you very much. I have another question for you.
Wonderful.
What is the advantage of using a horn antenna as compared to the new Ubiquity ISO-station radios?
I mean, there's no comparison, right? So the ISO-station radio is a CPE. It's not an access point. Our horn antennas are for access points, not CPE. So there's no comparison whatsoever.
Thank you. Got more questions for you. What is the difference between V2 twist port adapters and the originals?
Great question. I'm glad somebody asked that. So, when we first released this antenna technology, or this methodology of horn antennas to the market, the first twist ports were created with a frequency response range of 5.4 to the upper 5 gigs. So basically 5.4 to 5.9. The lower 5.1 to 5.25, or basically 5.3, wasn't available, or wasn't capable as far as the frequency response. So long story short, the two main differences is, if you have a V1, a version 1 early twist port adapter, the usable frequency range is 5.4 to 5.9. If you're trying to operate, or if you bought a horn early on and you're like, damn it, this thing sucks, it doesn't work, they lied to me, and you threw it away, you might check to see where, at the time, if maybe you were trying, a lower 5.1 to 5.3 channel. If that's the case, it wasn't designed to run there, and it was unfortunate that that wasn't understood. The second thing is that the co-location capabilities of the twist port adapters, not the horns, the antennas have not changed. The twist port adapter in V1 didn't have as good of an isolation as V2. So the co-location capabilities of a V2 adapter is much greater. It's over 10 dB better isolation than the V1. So it's possible that you have a V1, you're running at, channel 570 something, 57 something, and it's the only AP because you have a small thing, and it's working perfectly fine, and it should, because if you were in 5.4 to 5.9, it worked perfectly. If you weren't co-locating that with other antennas, you wouldn't have noticed the co-location isolation. So you might have a V1 that's working perfectly fine, but it will fall apart if you start to co-locate a lot more antennas on that tower, or you start trying to use a lower channel. So moral of the story is, no V1 adapters, use V2. If you have V1 adapters, please reach out to us. Again, info@rfelements.com, and we'll work on getting you V2 replacements.
Thank you very much, Tassos. It looks like I've got a final question here for you. When
Sure.
will the AF5X adapters be available?
Yeah, great question. So that one I think is a lot closer than the Ultra Horns, but essentially, so there's two new adapters now that you mentioned the AirFiber 5X. So we have two new adapters that are coming out, the AirFiber 5X twist port adapter, and we also have a twist port adapter coming out for the Mimosa C5C, which is their small connectorized CPE device, which my understanding is eventually it will also have a firmware flash to be used for point-to-points. So at this time, there are no point-to-point antenna products on the market yet for RF elements. We have our Ultra Dish, which is our version of a parabolic dish. That's a low-cost point-to-point antenna. And then we have the Ultra Horn. So really, until those antennas come to market, we're not going to bring the AirFiber 5X. So once the Ultra Dishes, which should come to market first, when they come to market, then we should have the first runs of AirFiber 5X and the Mimosa C5C twist port adapter. So hopefully in the next couple of months.
Thank you, Tassos, very much for answering those questions. And I'd also like to thank everyone for attending today. And if anyone has any other questions, please feel free to contact your sales rep or email us at sales@microcomtech.com. And if you wish to view any of the products mentioned or shown today, please visit us at www.microcom.us. And please remember, this webinar presentation was recorded and will be uploaded to our Microcom YouTube channel, so you can reference it again and view the whole thing again on YouTube. Thanks, everybody. Thank you, Tassos, and everybody have a great day.
Yep. Thank you, everybody. Bye.
Bye-bye. Thank you.